हो जाता था और मुझे बता दिया जाता था कि एस्टिमेटेड इतना रेवेन्यू आपने अर्न कर लिया है।
Section A, I have uploaded yesterday one video of 2-hour lecture on topic design of beams. So you are recommended to watch this video, as this video explains load carried by beam. So I have also uploaded on files folder of section A in class material design of beams PDF file, which I am showing you at the moment. So this file is also uploaded, its PDF version, and the recording of this topic up to slide number 11. So from slide 1 to slide number 11, these slides are explained in that recorded lecture. So today I want to discuss these first 11 slides as well as the next few slides up to slide number 16. So even up to slide number 16, I have just recorded 2-hour lecture with section B. I will also share with you that 2-hour recording, which is just recorded in the first 2 hours lecture from 8 to 10. So you can also watch the complete recording of these slides from 1 to 16. So this meeting is of 1 hour. So next week we will have 2-hour interaction. So I suggest you to please go through all the recorded videos and then let me know before lecture or after that if you face any problem in understanding the contents explained in that recorded lecture. So if I question you at the moment that are you clear about the contents in the video lectures which I explained online, or there are some problems which you want to discuss as homework, I have assigned other sections and to your section as well to solve all the problems in chapter 3, solved and unsolved ones. So only SI addition, SI units problems you are going to attempt. Some example problems are given in FPS system. Don't attempt them. Only SI addition problems you are going to attempt. Solved one and unsolved one at the end of the chapter, whether they are analysis or design problems, please attempt them as homework and then upload them on the assignment folder. Now first, if I question you that have you understood the topics I covered up till now under the heading of ultimate stand design of rectangular beams, singly reinforced, analysis and design. 31 students are at the moment online. You can unmute your mic. Team CDCIV.
Yes, sir.
जी कोई भी नहीं रेडी? फिजिकली तो इतने सारे प्रेजेंट थे, मेंटली मैं कह सकता हूं, बट आप क्यों नहीं हाथ खड़े कर? नॉट अ सिंगल स्टूडेंट. अब्दुल हन्नान साजिद, प्लीज अनम्यूट योर माइक. या एसन जट, प्लीज अनम्यूट योर माइक. या आमिर सुल्तान, या अनीस अहमद. सो आई थिंक काफी खौफनाक सिचुएशन है ये यहाँ पर. Okay, let me start today's lecture. So as I said that I have already uploaded the same topic, but just to give you a brief review of the same slides, I can start the recording again. So the topic today is very interesting, and its recording, as I said, is uploaded. Topic is actually very much applied because you have noticed that what I have discussed in design problems is a beam single span which is subjected to a uniformly distributed load, and magnitude of that load is provided to you. I remember that I have given you a load of 75 kilonewton per meter ultimate load, and against that load beam was designed. Now the question will arise that in practical life you will be given with the architecture working drawings only. So architect will prepare that drawings and it will hand over those drawings, and you need to then decide the structure system. Structure system means that whether the building will be a load bearing wall system or a beam column slab system, what will be how, whether the slab panel provide you dimensions, sizes, and in dimensions, room size, the structure system is not provided to you because it is your concept, your domain as a structural engineer to decide the load transfer path. For example, if in architecture working drawings, room dimension is provided to you, suppose 5 by 5 meter is the room size, but that drawing will not tell you that on that 5 by 5 meter room what will be the slab thickness. and how this 5 by 5 meter room slab will behave, whether it will bend in single curvature or double curvature, whether the load distribution, load transfer of that slab 5 by 5 meter is one way or two way. On the parameter of the slab, how load will be distributed. So architectural working drawings and the section through those drawings will tell you the thickness of the floor finish, that how much is the finish, and it may also tell you the type of the finish, that above the slab the finish will be brick ballast and then some terrazzo or roof tiles, or above the floor slab there is a PCC and then roof tiles. So this information is only provided on sections. Thickness will be fixed by the architect only of floor finish, but the thickness of the structural components like the roof slab thickness, beam cross sections, beam depths, column size, footing thickness, footing size, that is not the area of the architect, not the domain, or it is not his or her expertise to decide the dimensions or the thicknesses of the structural components. So if you are given with this sketch as shown on the slide number 2, that there are columns in architecture working drawings which are spaced at center to center distance of 6 meter by 8 meter. So that is what architect can tell you, that we have a column spacing at 6 by 8 meters. So this much clearance we need center to center between columns. Then as structural engineer, you need to think that whether I will design the slab of size 6 by 8 meter, one panel of size 6 by 8 meter, or I can put one beam exactly midway between center to center distance 6 meter, and I will divide this big panel into 3 plus 3 meter. So in this sketch, you will find that there is one beam which is resting on orthogonal beams, spandrel beams. You may state that the beams which are running on column center lines, they are primary beams, while there is a secondary beam which is running from beam to beam, and it has divided a big panel of 8 by 6 meter to 2 sub panels, each of 3 by 8 meter. By doing this, actually, you have made a panel size 3 by 8, and if you will take the ratio of the longer over shorter size of the panel after putting that secondary beam, you will get 8 by 3, and the answer will be greater than 2. If the aspect ratio, which is taken as the ratio of longer over shorter panel, is greater than 2, you will end up with a slab which will behave like a one-way slab. It means load distribution will be one way. Bending curvature will be single. So it means this 3 by 8 meter slab will transfer 50% of its load to the beam which is running on the column center line along the longer panel dimension, and 50% of its load to the interior beam, which is also resting on two primary beams and running along the longer panel dimension. Since slab is one way, so 50% load will be transferred to either end, and the shorter span will be the primary span, and half of the span will distribute its load to the supporting beams. If I remove this interior beam, then the panel dimension will become 8 by 6 meter. An 8 by 6 meter then aspect ratio will give me answer less than 2. If this answer is less than 2, then we will have a two-way slab. And two-way slab means that the load distribution is two-way. Bending curvature is double. So all the beams on the perimeter will get their share of load. Not just 50-50 will go to the opposite edges as in case of one way. Here the load distribution will be two-way. So it means decision about this interior beam has altogether converted a two-way panel into one way. And whether to introduce this beam or not, it is actually your decision as a structural engineer. What will be a cost-effective decision? That means that structural system which will be giving you less cost. You will decide the system according. Both are structurally adequate, but the selection will be made which will be the cost effective, based on which structure system is cost effective. So in this presentation actually we are discussing that how to estimate load on the beam. As in previous lectures, we are provided with the ultimate load directly on the beam, and we had no idea that from where that load comes. Now actually in this presentation we want to discuss calculation of this load on the beams which are part of a one-way slab system or which are the part of a two-way slab system. Now in this case, since beams are running along the longer edge, and they are taking 50-50% load because slab is behaving as one way, as aspect ratio is greater than 2. Next question will arise that how to calculate the load then. As I said, that as a structural engineer, you have to design the slab thickness. In slab design, which will be our next topic, your first objective will be to decide the thickness of the slab. First big unknown is how much is the thickness of the slab. And the next obviously is to calculate the area of steel. So thickness estimation is your domain. You have to decide the H. Floor finishes, as I said earlier, which are superimposed on that, will be provided by the architect. And then obviously on this slab, occupancy load you will decide based on the given guidelines regarding occupancy loads. So knowing the type of the building, structural use, you will select the live loads. Now to get UDL on the beam, the technique will be that I will convert the loads into pressures. So if I know the thickness of the slab, and as I said, you have to design the thickness first. You will calculate the thickness, and then after designing the slab, you will design the beams, then the columns, and then the footing underneath. If you have earlier designed the slab and you have fixed the thickness of the slab 6 inches, 150 millimeter, you will divide this thickness with 1000 to convert this into meters, and then you will multiply this thickness with the density of the reinforced concrete, which is 2400 kg per meter cube. So in this way, you will be able to get the result in terms of pressure, that is kg per meter square. So this decided by you 150. Density of reinforced concrete, you select it, and this is quite conservative selection of concrete density 2400 kg reinforced concrete density, and this is how you will get service self weight of the slab in terms of pressure. Then from the section details provided by the architect, you will be knowing that above the slab how much is the thickness of floor finish proposed by the architect and what type of floor finish he or she is recommending. So it means if I propose you that above this slab the floor finish thickness decided by the architect is 100 millimeter and its type is that there will be a brick ballast, and on top of it there will be some screed, some sand and mixture of sand and brick ballast, and then on top of it terrazzo. So it is a composite of ballast and terrazzo, or it is a composite of PCC plus tiles, and together the total thickness will become 100 millimeter. So based on the type of the proposed floor finish and the thickness, you can also estimate the corresponding superimposed pressures. For example, for this discussion, I assume that this composite floor finish of thickness 100 millimeter is a composite of density almost close to PCC, plain cement concrete. So I select the density of 2300 and I multiply it with the corresponding thickness, convert it into meters to get the corresponding self weight in terms of pressure over this roof slab. It is also in kg per meter scale. Then from the tables, design guidelines, and the type of structure, its structural use, if I select that for this slab system, the occupancy load is, which is the live load, is proposed 300 kg per meter square. So live load is given directly in terms of pressure. It means now I have the sufficient information. I have the dead self weight of the slab, floor finish weight, and the live load, and I have also the decision to design it by ultimate stand design. So I will call the second combination, which is 1.2 dead plus 1.6 live. So gravity loads are dominating. There are no chances of lateral loads. So governing combination is second one. So it means I will multiply all the dead loads with 1.2 and this live load with 1.6, and I will get ultimate pressure in kg per meter square on this room slab. So can you open your mic and then let me know first what will be the answer of this 150 over 1000 into 2400. I have done this you can say example problem with section B and with section D as well, and I have uploaded that recording and will also share with you. So but just in this 1 hour interaction you can also do the same work, but later on please watch the complete video up to slide number 17. So add down, let me know what will be the answer of the thickness of this divided by 1000 into 2400.
360.
Good. 360 is the self weight of the slab. And how much is the floor finish? 230.
Yes, sir.
So 360 plus 230 total dead load service is estimated, and I will multiply it with 1.2. Then I selected a live load of 300 kg and I will put it here to get a resultant of, I think, 1188. Just check 1188 kg per, right? So this answer is in terms of ultimate pressure in kg per meter square. Normally we use in kilonewton per meter square. So I can multiply this with 9.81 and then I can divide this with thousands to convert it into kilonewton per meter square. So then the answer will be WU. It will be almost 11.65 kilonewton per meter square. So this 11.65 kilonewton per meter square is the ultimate pressure which is on this hatched area and also on all the unshaded areas. This is the pressure present everywhere on this panel. But just to tell you how to get UDL on the beam, I will multiply this pressure transverse, which incidentally in case this transverse width comes out to be 1.5 from adjacent panels, so it is total 3. So it means UDL on this beam to design it will be then 11.65 into 3, almost I can say 34 kilonewton per meter. You can imagine that this much exercise is additional which you need to carry out in your practical life, because in practical life no one will tell you that please design a beam subjected to ultimate load of 75 kilonewton per meter. It is your headache to calculate this. And on this simple example problem, I tried to explain that you finally got this UDL on this interior long span beam, a magnitude of 34 kilonewton per meter as the ultimate load. Now you can assume that the end conditions of these beams are still simply supported, although this beam is resting on other beam. And we are going to discuss in next lectures that how to deal with such end conditions. But if at the moment I assume that I will release all the movement at ends and I will still consider it as a simply supported beam, then it means this 8-meter span beam is to be designed for a ultimate uniformly distributed load of 34 kilonewton per meter. Now you can calculate WL square by 8 as the mid-span maximum moment to design this beam as singly reinforced beam. This is what I have discussed with the sections in 2-hour lecture. One more point which is important here. If you are, sorry, this is a mistake. I will remove this. This is exterior beam. Now, if you are designing exterior beam, edge beam, obviously the edge beam only has slab on one side. So it means this load will be divided by 2. It will drop to 17 kilonewton per meter because there is no continuity on the other side. But if in this slab system there are projections, cantilevers projecting out from the edge of the slab like shades, then that 100% cantilever load will also be transferred to the edge beam. So that is the reason it is mentioned here half of the panel dimension in this particular structure system plus a cantilever width. Suppose that there is a cantilever projecting out and that cantilever has a span of 1 meter, then it means 0.5 meters. It means the transverse width, which will be multiplied with this ultimate pressure of 16.5 will be then 11.65 will be then 2.5 into 11.65 if this slab system has the 1 meter projection beyond the edge of the exterior beam. So this is how we are going to estimate load on the beams if these beams are the part of a one-way slab system. So you may have one argument that then what will be the load on the short span beam in this particular structure system? It means in this particular structure system along the short span beams which are present, they are in this particular system, I am telling you, they are carrying their self weight, but also don't forget, this is only for this unique system which is shown in the slide. So I'm sketching a beam from this column to this column. So it means this beam will carry its self weight and the point load of this beam which is resting on it. So it means 34 divided by 2. So 17 kilonewton will be the reaction which will be present at of this 6 meter span beam. If, for example, I'm talking that only for this particular sketch, you assume that there was a column here and there is a column here and beam is directly resting on the column and there are no such spandrel beams, then obviously this short span beam only has its self weight, nothing else. So only the long span beam will have 50% load and short span beam will carry only its self weight, particularly in case of a slab system which is one way. And then onward, if we have a aspect ratio which is less than 2, actually you will see that it is shown here greater than or equal to 2, but again it is given here less than or equal to 2. Actually equal to 2 is a boundary line. You can assume that equal to 2 is still one way and less than 2 is predominantly two-way. And if, for example, for this particular example problem, I tell you that the long span, which is Ly, is 5 meter, and the short span, which is notated with Lx, as 3 meter. So this comes a slab system with 5/3 ratio, which is less than 2. So it is then a two-way slab which will distribute the load two-way. Its bending curvature will be two-way. And to decide how much load will be transferred to the long span beam and to the short span beam, it is safe to assume that a line drawn at 45° from corner, and draw such lines from each corner, and where they intersect, join them with the other opposite corner, and in this way you will divide the slab into number of triangles and trapezoids. So if Lx will become equal to Ly, like a square panel, then obviously you will not get any trapezoid but all four triangles, because when you will radiate out lines at 45°, you will not get any trapezoid. The apex of the triangles will intersect with each other. So all such slabs are two-way. So this unique square panel will distribute 1/4 of its load to each perimeter beam. In this case, bigger load will go to longer beam and relatively less load will go to short span beam, like triangles will contribute their load to the short span beam if the aspect ratio is less than 2. Here there is a little challenge. Is that on this short span beam, it means this beam is then subjected to a wearing load. Edge beam subjected to one triangle and interior beam subjected to two triangles. And this long span beam, edge beam subjected to one trapezoid and interior subjected to two trapezoids. So you need to then write the moment equation and get the maximum moment at the mid span against this wearing load. So it will be a little tedious to get the maximum moment at mid span when beams are subjected to wearing loads. To convert them into UDLs in such a way that the mid span movement will remain the same, that is explained in the next slides. That we are going to convert these triangles or trapezoids into equivalent UDLs so that the mid-span maximum moment will remain the same and the solution of moment estimation will be more convenient. Otherwise, if you are comfortable with the triangles or trapezoids and you can get the maximum moment, you are welcome. Or you can follow the conversion of the triangles or trapezoids into equivalent UDLs and then determine the mid-span maximum moments which are of same magnitude as otherwise you will get by solving the triangles or trapezoids. So this is explained in the next 8 to 10 slides. So please go through the recordings and then let me know if you face any problem in understanding the contents. So this are almost half hour recording is also uploaded, and I will also share the 2 recordings which I recorded with section B, and already I have shared with you on the same topic the recordings of section D. So there are so many recordings, so it is up to you how you will watch them and follow them. I repeat that it is your career, it is your reputation actually when you will pass out, and how you will then face the real life challenges. If you are not too much attentive at the moment, then you will face too much difficulties in your practical life. So please keep following the recordings, at least if you want to get at least 80 to 90% of the lectures delivered. So I have taken your online attendance, so let me end the meeting. Allah.